Hello everyone, welcome back to my YouTube channel. In this video, we will learn counting sort, a fast and easy way to sort numbers, and I will explain how it works step by step with examples so even beginners can understand it. Now I give an introduction to the counting sort. Counting sort is a non-comparison based sorting algorithm that sorts elements by counting how many times each value appears in the input array. Instead of comparing elements with each other like bubble sort or selection sort, counting sort uses the actual values of the elements to determine the correct positions. This algorithm works by creating separate counting array to store the frequency of each number, and using this count information, it places each element directly into its correct position in the sorted output array. Counting sort is very fast and efficient when the range of input values is small and known in advance. Because of this, it is commonly used in situations like sorting exam results, ages, or ratings where values fall within a limited range. However, counting sort is not suitable for all cases. It requires extra memory and work only with non-negative integers. When used in the right scenario, counting sort can sort data faster than many traditional comparison-based sorting algorithms. Now I'll explain you about when counting sort is used. Counting sort is used when the input data meets specific conditions. It is more effective in situations where the values are integers within a small fixed range. Counting sort is used when the range of value is small and known. If the maximum and minimum values are limited, counting sort becomes very fast. As an example, exam marks lay between 0 and 100, student grades are between 0 and 10, and the ratings are between 1 and 5 stars. Then the next example is the data consists of non-negative integers. Counting sort works directly with numbers, not comparisons. For example, ages of people, they lie between 0 and 120, number of items sold per day, and the product quantities in a store. Then large amount of data with repeated values. If many elements repeat, counting sort performs extremely well. For example, votes for candidates, survey results, inventory items count. Then the stability is important. Counting sort is a stable sorting algorithm, meaning it preserves the original order of equal elements. For example, sorting students by marks while keeping registration order. Then the speed is more important than memory. Counting sort has linear time complexity with O(n) plus k, making it faster than comparison-based sorting when conditions are right. Now I'll explain you about the key idea behind the counting sort algorithm. The key idea behind counting sort is counting instead of comparing. Instead of comparing elements with each other to decide their order, counting sort counts how many times each value appears in the input array. Using these counts, the algorithm then calculates the exact position of each element in the sorted output. In simple terms, it counts how many times each number occurs, then it uses the count information to place numbers directly in their correct positions. Because it avoids comparisons, counting sort can sort data faster than traditional sorting algorithms when the input values are within a small known range. Now I'll explain you about the assumptions about input range in counting sort. The input values are integers, values are non-negative, the maximum value is known, and the range of values is small. Now let's suppose you are given this array and you want to sort this. In this array, when you count the elements of this array, you can see that there are 4 zeros, 5 ones, and 3 twos, and so on. And the number of elements in this array are 17. Range of the array is 1 to 7. That means the minimum value is 0 and the maximum value is 7. So you can the value k. Let's start sorting this array. This is the array that we have, and it ranges from 0 to 9. So the k value is 9. The number of elements in this array is 17, so n equals 17. This is the initial count array that I used here. So let's continue completing this count array. The 0th index contains 2 here. So in count array, update the count of 2 as 1. Then the next element is 1. So update the first index of this array as 1. Then there is another 1 in the index 2 of array A. So you must again update the index 1 value of the count arrays as 2. You must increment the value by 1 after meeting the same element. So let's move into the next element. When it is 0, in counting array, this 0 index contains the value as 0. After you meet a value of 0 in the array A, you must increment it by 1. Then the next element is 2. You must increment the index 2 of the count array by 1. The count array, then the value should be 2. Then you will need 5. So you must update the count array here as 1. You increment the index 5 of count array by 5. Then you must move into the next element. The element is 4. After meeting 4, you must increment the count array by 1. After meeting 4, you update the fourth index of count array as 1. Then the next value is 0. Then again you must increment the 0th index of the count array by 1. Then the next element is 2. So you must increment index 2 by 1. Then you move into the next element. It is 8. So you must increment the value of index 8 by 1. Then after 8 it is 7. Then you must increment the 7th index value by 1. Then it's 9 and you should increment the 9th index by 1. There's another 7 here, so you must increment the 7th index by 1, so it is 2 now. Then you can see that the next element is 2. After meeting 2, you must increment index 2 of the count array by 1, so it is 4. Then the next element is 0, so you must increment the 0th index by 1, so it is 3. After 0 it is 1, so you must increment the first index of count array by 1, so it is 3 now. The final element is 9, so you must increment the 9th index of count array by 1. So it changes from 1 to 2. Then this is the count array. In this array there are 3 zeros, 3 ones, 4 twos. There are no 3's. They are in the array A. There are only a 1 4 here, and there is only a 1 5. And you can see that there are 2 9's in the array A. Let's update by using this count array. You can see that the final appearance of our sorted array is this. There are 3 zeros, 3 ones, 4 twos, no 3's are there, only 1 4 here, and there are 2 9's. Let's update our counting array again. You must take the first element of counting array as this. Then you must add this 3 and this 3. It is 6. Then you must add this 6 and 4. Then it is 10. You must add 10 and 0. Then it is 0. You must add 10 with this 0. 10 plus 0 is 10. Okay. Then 10 plus 1 is 11. 11 plus 1 is 12. 12 plus 0 is 12. 12 plus 2 is 14. 14 plus 1 is 15. 15 plus 2 is 17. Then this is the updated counting array. So now I tell you how the elements are added to the sorting array by using these two arrays. And it means the array A and count I. Here it is started from the right corner of the array A. The rightmost element of the array A is 9. So you must go through the 9th index of count array. So it is 17. You must decrement 17. After that it is 16. So you must add 9 to the 16th index of the sorted array. Then the next element is 1. You must go to the first index of the count array. So it is 6. You must add 1 to the 6th position of the sorted array. Then the next element is 0. You must go to the 6th index and it is 3. You must decrement it and it is 2. So you must insert 0 to the index 2. Then the next element in the array A, when going to right to the left, is 2. So you must go to the second index of the count array. It is value that positioned in the second index is 10. So you must add 2 to the 9th position of the sorted array. Then the next element is 9. Go to the 9th index is 17. After we added 9 before to this 17th position, it becomes 16. Then another 9 is here. So when again comes to the 9th index, this change before this changes into the 17 into 16, then again decrement 16 by 1, so it is 15. So add 9 to the 15th index of the sorted array. Then it is 7. Go to the 7th index, it is 14. Decrement 14 by 1, so it is 13. Add 7 to the 13th index. Then it is 7 again. Go to the 7th index. After adding 7 to this 13th index, this 14 becomes 13. And again decrement at 13 with 1. Then it is 12. So add 7 to the 12th position of the sorted array. Then it is 8 here. Go to the 8th index of the count array. It is 15. You must decrement 15 by 1, so it is 14. You must enter 8 to the 14th index of the sorted array. Then it is 2 here. Now I think that you understand how the sorted array is created using the original array and the count array. Now I'll explain you about the purpose of counting array. The counting array is used to store how many times each value appears in the input array. Instead of comparing elements, counting sort uses this array to keep track of the frequency of each number, help determine the correct position of elements in the sorted output, make the sorting process faster and more efficient. Finally, the main purpose of the counting array is the counting array tells us how many times each value occurs. Now I'll explain you about the prefix sum, which is also known as the cumulative count array. In counting sort, the prefix sum array is created from the counting array. It tells us the final position of each element in the sorted output. Instead of just knowing how many times a value appears, we know where it should be placed. In simple words, the cumulative count array tells us how many elements are less than or equal to a given value. Now I'll explain you about building the output array in counting sort. After creating the counting array and the prefix sum, which is also known as the cumulative count array, the final step is to build the sorted output array. The output array stores the elements in the sorted array. Now I'll explain you about the time and space complexity analysis of counting sort. First I explain you about the time complexity. Counting sort runs in linear time under the right conditions. Because the algorithm scans the input array once, builds the counting array, creates the prefix sum array, and builds the output array, we can conclude that based on this information that the time complexity is big O n plus k. Here, n means the number of elements in the input array and k means the range of input values or the maximum value. Now I'll explain you about the advantages and limitations of counting sort. First I explain you about the advantages of counting sort. It is very fast, small ranges. Counting sort runs in big O n plus 1k n plus k time, which is faster than comparison-based sorting algorithms when the input range is small. The next one is no comparison required. It doesn't compare elements with each other, making it more efficient in suitable cases. And the next advantage is stable sorting algorithms. Counting sort preserves the relative order of elements, which is important in many applications. The next one is simple and easy to understand. The logic is straightforward: count, accumulate, and place. The next one is used in other algorithms. Counting sort is the key component of radix sort. Now I'll explain you about the limitations of counting sort. The first one is high memory usage. It requires extra memory for the counting and output arrays. Then it is not suitable for large ranges. If the value range is very large, counting sort becomes inefficient. It works only with integers. It cannot directly sort floating point numbers, rings, and complex objects. And the final one is range must be known. The maximum value must be known or easily found before sorting. Let me give a short summary for advantages and limitations of counting sort. As advantages, we can take that it is fast, stable, and no comparisons. And the limitations of counting sort are extra memory, small range only, and the integers only. That's all for today. Thank you so much for watching. I hope you now understand counting sort clearly. If you found this video helpful, don't forget to like, share, and subscribe for more easy to understand algorithm tutorials. And see you in the next video.